Welcome to the presentation on Introduction to Objects. We're going to start with an overview of object-orientated principles in order to show you the big picture. The information we've managed in a Java program is either represented as primitive data or as objects. And we're going to start with objects since objects are the building blocks of object-orientated programming. An object is defined by a class, which is like the data type of the object. A class is a model or a blueprint from which an object is created. It establishes the kind of data the object of that type will hold and defines the methods that represent the behavior of such objects or the operation that can be performed on them. An object is a basic part of a Java program. An object represents something with which we can interact in a program. An object provides a collection of services that we can tell it to perform for us. A software object often represents a real object, such as a bank account, and every object has a state and a set of behaviors. By state, we mean state of being, which are basic characteristics that currently define the object. For example, part of a bank account's state is its current balance. The behaviors of an object are the activities associated with the object. Behaviors associated with a bank account probably include the ability to make deposits and to make withdrawals. Using objects, the services are defined by methods in a class that define the object. A class represents a concept, and an object represents the embodiment of a class. A class can be used to create multiple objects. So here's a visualization of a class and objects. So the car class is simply a blueprint or an idea from which the objects can be created. A class is not an object, no more than a blueprint is an actual house. A class contains no space to store data. Each object has space for its own data, which is why each object can have its own state. And we make objects from the class or from the blueprint. So from that class blueprint, multiple objects can be created. So from the car class that we see on the screen, we're able to create a Mercedes object, a BMW object, and an Audi object. Here's an example using the system.out object that we've already worked with a little bit. The system.out object represents a destination to which we can send output. In the Lincoln program that we see over here on the side, we invoke the println method of the system.out object. Within that statement, system is a class in the java.lang package. Out is a static member of the system class and is an instance of Java.io print stream. Println is a method of the Java.io print stream. This method is overloaded to print messages to output destinations, which are typically a console, monitor, or file. The println method will print either a string literal, such as whatever you are, be good one, as shown in the example here, or a variable in the parameter, and then advances the program to the next line. Advancing the program to the next line is what the ln in the println statement does. The print method, notice there's no ln on the end of it this time. The system.out object provides another service as well. The print method is similar to the println method, except that it does not advance to the next line. Therefore, anything that is printed after a print statement will appear on the same line. Character strings. Every character string is an object in Java defined by the string class. Every string literal, delimited by double quotation marks, represents a string object. So a character string is an object in Java defined by the class string. Because strings are such an important part of computer programming, Java provides something called a string literal, which appears inside double quotation marks, as we've seen in previous examples. And we're going to explore string literals in greater depth a little later. String concatenation. The string concatenation operator, which is the plus symbol, is used to append one string to the end of another. It can also be used to append a number to a string, and a string literal cannot be broken across two lines in a program. So let's look at an example. So here we've got a very long string, and we've got our system.out.print line, and we can see that we've got two halves to our string. We present the following facts for your is the first half of the string, and the second half is extracurricular edification. But we've had to use the concatenation operator because all of that string would not fit on one line without causing us to scroll a long way across. So a character string within a double quotation mark cannot be split across two lines of code. If you just were to hit your enter and go to a second line without concatenating it, you would actually get an error message. So one way we can get around this problem is to use that string concatenation operator. Again, that's the plus symbol that we put between strings. String concatenation adds one string to another string. Here's another example. We can also use the string concatenation operator to combine text and numbers. Note that the numbers in the last couple of lines on the screen are not enclosed in double quotes and are therefore not character strings. In these cases, the number will automatically be converted to a string, and then the two strings are concatenated. Digits are characters and can be included in strings as needed. Thank you for listening to this presentation. Remember, knowledge is power, and you've got this.